pressure switches, rollout switches, and safety. Welcome to class. Today's focus is all about furnace safety controls, specifically the pressure switch, the rollout switch, and other key safety devices that protect the system, the home, and most importantly, the people inside. Let's begin. Why safety switches matter. A gas furnace works by creating a flame, and with flame comes risk: carbon monoxide, overheating, explosions, and fire. To avoid any danger, modern furnaces have multiple safety switches built in. Each switch monitors a specific part of the furnace and shuts everything down if something goes wrong. Let's explore each one. 1. Pressure switch verifies airflow in the vent system. The pressure switch is one of the first safety devices activated during startup. Here's how it works. When the inducer motor starts, it creates negative pressure inside the flue pipe. The pressure switch detects this vacuum, and if airflow is sufficient, it closes the switch, telling the control board it's safe to light the burners. If there's a blockage or the vent pipe is clogged or disconnected, the pressure switch will stay open, and the control board will stop the sequence immediately. Technician tip: check for clogs in the flue pipe, check the tubing connected to the pressure switch, and confirm voltage before and after the switch. 2. Rollout switch detects burner flame escaping the chamber. The rollout switch is a small disc-shaped switch located near the burner compartment. Its job: to detect if flames are rolling out of the burner area instead of staying safely inside the heat exchanger. Flame rollout is extremely dangerous. It could mean a cracked heat exchanger, a blocked flue, or even reversed airflow. If the rollout switch detects high temperatures near the burner shield, it will cut power immediately to the gas valve. You'll see the burners shut off instantly. Technician tip: if the rollout switch has tripped, do not reset it without checking for the real cause. 3. High temperature limit switch prevents overheating. Located inside the supply plenum or above the heat exchanger, this switch measures the air temperature leaving the furnace. If the temperature gets too hot, usually above 170 to 190 degrees Fahrenheit, the limit switch opens and shuts off the gas valve. Overheating might be caused by a clogged air filter, a bad blower motor, or blocked return ducts. Once the furnace cools down, the switch resets automatically. Technician tip: use a temperature probe to verify readings and check the airflow system for restrictions. 4. Auxiliary limit switches extra protection. Some furnaces include additional limit switches near the blower, the vent motor, or inside compartments. These are called auxiliary limit switches. They act as backup safety controls and may trigger a hard lockout if tripped. 5. Flame sensor confirms ignition. We discussed this in class 26, but it's worth repeating here. The flame sensor detects whether the burners have ignited. If it doesn't sense flame within 3 to 5 seconds, it shuts off the gas instantly. No flame equals no gas. It's that simple, and that safe. How to diagnose safety switch issues. If your furnace stops in the middle of a heating cycle or never ignites, follow this checklist. Check the control board lights. Count the flash codes. Inspect the pressure switch tubing and inducer operation. Test the rollout and limit switches for continuity. Watch for flame rollout or overheating signs. Use your multimeter to test all switches for voltage in and out. Check the filter and airflow system. If any safety switch is open, the furnace will not run. That's not a failure, that's the system doing its job. Quick recap: safety switches and what they do. Pressure switch confirms airflow. Rollout switch stops flame escape. Limit switch prevents overheating. Auxiliary switches, extra layers of safety. Flame sensor confirms successful ignition. Each one is essential. Each one keeps your customer and your equipment safe. Final thought: never bypass a safety switch. Never jump it just to see if it works. That's not testing, that's risking. As a professional technician, your job is to find the reason the switch tripped and fix it. Your skills will keep homes warm and safe.